Hello, I am Akash Devre. I am recording this presentation as part of my final presentation for cloud computing course. Uh, Today, I am uh, discussing web architecture for Datacoral, which is serverless and event-driven data pipeline for modern data engineering. We can also see the topic of discussion is also embedded here. Like I have attached a YouTube link here in this name of the architecture. Our focus is how Datacoral is running entirely on Amazon Web Services, delivers low latency, highly scalable data integration with virtually zero operational overhead. Uh, and I hope by the end of this talk, uh, this will be, clear, and we can see how serverless event-driven mindset is fast becoming the norm of consistent contemporary, data teams. So moving forward, so let's go through the path that we will be following. So first is introduction to Datacoral and what the platform is and why it matters. Second is the business problem, the real world pain points that we are addressing uh, throughout this video and this in this architecture. Third is architectural overview, a look at the AWS building blocks, how the core components of this architecture are built. Then we will be deep diving into the use case, replication of MySQL into Amazon Redshift, how the data is being replicated from MySQL to Amazon's Redshift that we will be discussing. And after that, we will also be looking into problems that this architecture solves, such as latency, scale, security, and operational burden. Uh, After that, we will be seeing real-world impacts, architectural best practices, security considerations, and uh, after covering this, we will also look into uh, how this architecture, how much cost it requires to build this kind of architecture, and actual running cost using AWS cost, uh, you know, estimate, that tool we use to calculate. And last will be key takeaways that I have learned or my perspective about this architecture. So Datacoral is fully managed data engineering platform that extracts information from more than 80 different sources, anything from operational databases like PostgreSQL, MySQL, to SaaS tools such as Salesforce or Marketo, and even raw files in Amazon S3. Without writing a single line of glue code, customers can funnel this data into analytics warehouses like Amazon Redshift or Snowflake, ready for dashboards or machine learning workflows. The strategic advantage is speed plus simplicity. Datacoral installs uh, directly inside the customer's own AWS account, so no data leaves the virtual private cloud. At the same time, because the platform is almost 100% serverless, it scales automatically with workload and it scales down to zero when idle. So going through this, actually, why do we need this architecture? Do we really have any problems that we are solving with this architecture? So yes, modern companies operate in real time. Marketing, products, and operational teams expect fresh numbers in minutes and not hours. So the data which is being fetched uh, should be latest, so we can work on the data on and we get insights regularly. So this requires you know uh, that we need low latency of data, and what all dashboards must have refresh within 5 minutes, so leaders can decide quickly what business decisions they make based on those data. If data lags, they can't decide what to do in a correct manner, what what should be done. Then next thing is scalability. Data volumes never stops growing, so pipeline must handle billions of rows without redesigning. Next advantage or solution is zero operational. So classic ETL involves cron jobs, which needs long running servers and manual babysitting. So we need to set up those jobs. We need to verify manually whether if the job is failing, we need to rerun entire job. So that is tedious. So that is also costly, fragile, and distracts engineers from the high value work. And last one is security and compliance. So regulations that demand data stay inside control network, encrypted at rest and in transit. So these are what problems actually businesses face, and Data Coral is trying to solve these problems with the help of their uh, architecture. There are a few more business challenges here. So that is to make things concrete. Imagine a software as a service provider with hundreds of MySQL tables, changing in every few seconds. The goal is to land those tables inside Amazon Redshift every 5 minutes. Uh, so with no human intervention, and keep end-to-end latency below that same 5 minute window. That is the benchmark Data Coral sets for himself themselves, and we will later also see what it achieves target at truly massive scale. Going forward, we will look into the architecture of Data Coral, what components they have, and how they are managing, what all services they are implementing of AWS, what uh, different services they are utilizing in this architecture. So first is AWS Lambda. AWS Lambda, all of you know that it is a stateless functions that reacts to events and execute orchestration logic. So they are basically implementing Lambda to, oh, let me just zoom into this. So this is actual screenshot which I have taken from the video, and this is the one architecture that I came up with. I found into one of the sites. So Data Coral actually uses Lambda functions to uh, that reacts to events and execute the logic which uh, any company is trying to you know uh, run behind to get the data in particular format. Then they utilize Amazon S3 storage, which provides durable staging with 11 nines durability. So it is very reliable in terms of storing data into large volumes. and it offers, as I said, 11 nines. So it is very capable of storing your data, and retrieval is also very easy task. The third thing is they are utilizing DynamoDB, which provides a millisecond latency metadata, and it uh, stays state store. Fourth thing they are utilizing is Amazon Redshift RA3, the analytics warehouse with decoupled compute and storage. And last thing, which is not here in the points, but I got this here in this architecture, is okay. Okay. So here we can see the last thing is Amazon SQS, a reliable queue for fan out and back pressure control. So these services, live inside the customer's private VPC, and there are no public endpoints. All the traffic is internal. So this way they are building their architecture, keeping the data securely inside the customer's VPC. After this, we will move forward uh, with the actual orchestration workflow. So let me talk through a full 5 minutes cycle. So orchestration Lambda wakes up uh, on a schedule and reads configuration stored in DynamoDB. So from here, actually, this is the orchestration Lambda function. From here, actual their uh, workflow starts. So this Lambda function, reads configuration stored in this DynamoDB database. It limits an event to the MySQL connector Lambda, which is this one. So they are, in general, they are utilizing 3 Lambda functions here. And the connector fetches then the metadata, splits the task into batches, one batch per table or even multiple batches for very large tables. Then parallelism increases speed, isolation limits blast radius if a batch fails. Then each batch, writes raw data to Amazon S3. After the last batch finishes, the connector signals to the orchestrator that an event, uh, the orchestra that the table is ready. And once the table is ready and it is in format, the orchestrator then publishes an event to the Redshift loader Lambda. The loader issues a copy command from S3 into the destination Redshift table. Then a success matrix contains row counts, duration, schema, drift, uh, and are recorded back into the DynamoDB and surface through the dashboard or CloudWatch alarms. Because everything is event driven, metrics are straightforward. And if one batch fails, only that thread is rerun. The remaining remains intact. So we'll move forward. Now, the next is real world implementations of this architecture. So what does this look like in production? So as we are utilizing AWS infrastructure and serverless services. So latency is really low in this case. Source to dashboard is, in a few minutes, we can say less than 5 minutes latency. Then the throughput is 500 billion plus rows monthly, which is, massive data, which gets replicated across all customers. Third is reliability. So as the data never uh, leaves your customer's VPC, we can say the data is secure and very isolated, with customers managed KMS keys and encryption. And also it is also independent. Processing means no duplicates and no data loss. So these are the major, implementations that this architecture is had. Moving forward, we will be seeing key benefits this architecture provides. So let's summarize the benefits under, three headings. That is ultra low latency, bulletproof reliability, and uh, massive scale at predictable cost. So yeah, so ultra low latency means 5 minutes refresh for all the data. Like the data gets refreshed in every 5 minutes interval in near real time analytics, rather than previous ETL cron jobs that's used to takes around 24 hours, and it is very faster for business decisions. And customers also feel satisfied that data, as the data gets refreshed uh, every few minutes, the customer can always get a latest version of the data. uh, so it is very satisfying for the customer. Second key benefit is bulletproof reliability. So batch level isolation and independent writes confine failures to small units. Reruns are automatic. So no partial failures occur. We can rerun a single thread, and that is why even if a single job fails, it doesn't affect other batches, because we are running data batch wise. So if one batch is failed, we can always run that batch only, and this helps us to keep the data loss or duplication uh, to the minimum, or we can say no data duplication or loss happens here. And third key benefit is about massive scale at predictive cost. So serverless compute scales horizontally for peak and then scales zero when it is idle. So we just need to pay by the millisecond use. Then SQS events, which we talked about earlier as well in the architecture, lets you to trigger uh, downstream machine learning features. Then it alerts or additional ETL without adding any cron jobs. So it is very cost efficient, and we can set event driven alerts as well with this architecture. So what are the best architectural practices this data coral architecture follows? Data corals design applies several principles that you can apply to your own projects, such as serverless first, which is preferred managed auto scaling services to long running hosts. Second is event driven, which replaces brittle cron claims chains with messages or triggers. Third thing is independent design. So each and every job can run twice without harm. So retries are safe. And last thing is deep observability, push logs, metrics, and traces into CloudWatch, alerts on anomalies properly. Moving forward, we have security framework. Security is never an afterthought. Uh, so we should always focus on securing our architecture or our application while we are building it. So we should not neglect any security aspects. So here also they are providing various security features in their architecture. So first is in VPC development. The entire stack sit inside, your private subnet. So no public IP addresses. So uh, as these are sitting in your local VPC and which is private using private subnets, third party access, is avoided using this. Then second is KMS encryption, which is also one of the best practices which AWS provides, which customer or AWS managed keys secure data in S3, Redshift, and DynamoDB. So with this KMS encryption, we can secure our storage and other platforms. Third is least privilege IAM. So each Lambda function receives only the permission it requires and nothing more. So that way we can, only provide the least access under the zero trust model. And last one is private networking. Uh, yeah. So VPC gateway and endpoints prevents traffic from transitioning the public internet. These controls help satisfy the industry regulations such as GDPR, HIPAA, and SOC2 without extra appliances. Moving forward, we have our cost background, what this architecture actually cost. And as I mentioned, I have uh, created this cost estimate using AWS cost estimate. And I have also added a screenshot of my estimate along with the link to my uh, estimate here. So I will quickly, go through this and explain what all cost is uh, required for this architecture is. So AWS Lambda, which is a main, service in this architecture, charges in milliseconds of execution time. Then it comes with S3 that charges as per gigabytes of data stored and transferred. So data in is free for AWS. We can add whatever amount of data we want to store in our S3 bucket. But while we extract the data, AWS charges us for that data extraction. So we need to remember this thing. So third is DynamoDB on demand, charges per read or write unit. So whenever a read or write operation perform on the database, then the DynamoDB will charge you data. When the data sits inside DynamoDB, we won't be charged for the data. Fourth service is Redshift RA3, which enables you to separate sizing of compute and storage. So we don't pay for unused capacity. When we run the numbers of processing around 500 billion rows per month, which was stated by the engineer of Datacoral, uh, the fully loaded pipeline was still lower than maintaining a small fleet of EC2 instances because the instances would be running 24 by 7 even when no loads are active on this servers. But with this serverless infrastructure, the meter stops the moment the last batch completes. So that saves us a huge amount of, infrastructure cost and, maintaining servers. So here we can see the Amazon Redshift service uh, requires one node. Instance types I have taken as, RA3 large. Then utilization I have kept on demand only with 100% utilization per month. And pricing strategy I have kept as on demand. And the storage size I have taken as 3000 GB, which and this service is located. I have kept the location as for all of my services. I have uh, taken the one which is closest to me, that is US East North Virginia. So this Amazon Redshift service requires zero upfront cost. But as we are utilizing this service with this configuration, this is one of the major cost which we spend uh, in this architecture. It is around 70 to 80% of our entire cost. It is around $2,500. Then second service on which we spend a bit of money is the Amazon S3 service, where I have kept the storage service as standard storage with 3000 GB per month storage capacity, and it is also located in US East North Virginia region. As I have stated, that S3 is completely free when you store the data, so we don't need any upfront cost in this service as well. But as we need to retrieve data time to time basis, this cost around $70 per month. Talking about AWS Lambda, so I have configured it like invoke mode buffered, then architecture as 86, then number of requests per month are 500 billion per month, then amount of storage that this Lambda functions required, I have kept as by the default value 500 MB. And it also doesn't require any upfront cost as you are using pay as you go model of our AWS. But this Lambda service requires us to pay around $800 per month, and so for the rest of the services. So this cost for, entire cost for this architecture sums up to around 3,500 monthly. And if we consider the cost for an entire year, it is just uh, under $42,000, which is, considered to be, very less when we, think about big organizations where they spend billions and billions of dollars on server maintenance fees, and, manpower is also required to maintain those servers. So this architecture, proves us that we can use this cost efficiently, and it is very, you know, uh, uh, it goes very easy on our pockets. So my takeaways from this architecture will be like very simple lessons. First one is, event driven over cron jobs. So events are immediate, scalable, and self-healing. So event-driven bits cron jobs is what I have learned. Second is serverless removes toil, which focuses on business logic. Let AWS handle the capacity, patching, and fault tolerance. So as we are using our serverless model, we don't need to manage the servers, which requires if we are using EC2 servers. Then security stays on premises because we are utilizing this service inside customer's own private VPC. So we're, by deploying inside customer's VPC, Datacoral keeps data private while still offering the SaaS convenience. And last one is scalable patterns. The pattern extends. You can swap MySQL for Kafka, Salesforce, or even streaming APIs. The same Lambda plus S3 plus Dynamo DB backbone applies for every service. We just can, place what API model or structure we want to utilize. And this sums up my uh, explanation on this topic. Thank you for giving me chance to explain and learn about this uh, architecture. I hope this walkthrough has clarified how Data Coral, marries serverless technology with data engineering best practices to deliver low latency, secure, and cost-effective pipelines. Uh, that's it from me.